Assalamualaikum and good morning to everyone. My name is Swardi Kaharudin from School of Electronic Engineering, University of Science, Malaysia. I am pleased to present to you today a study titled Evaluating the Effectiveness of Exponentially Weighted Moving Average Filter in Enhancing Landslide Detection from Accelerometer Data. This research focused on landslide events detection, which are major natural hazards that can cause severe damage to infrastructure, loss of life, and economic disruptions. To minimize the impact of landslides, early detections and warning systems are crucial. However, conventional techniques for landslide detections, such as visual inspection and geological surveys, are often time-consuming and expensive. Therefore, there is a pressing need to develop automated and cost-effective techniques for landslide detections. In recent years, researchers have explored the potential of using satellite image and remote sensing technologies to detect and monitor landslides. These approaches have shown promising results and are particularly beneficial in regions with limited ground survey capabilities or difficult access. Now, let me introduce our proposed system for landslide detection using accelerometer sensors. While accelerometer sensors offer valuable data, the accuracy and reliability of the system can be affected by the presence of noise in the raw accelerometer data. To overcome these limitations, we propose the use of exponentially weighted moving average digital filtering approach. This filtering technique is expected to improve the accuracy and reliability of the system by providing a more reliable data. Our proposal system includes multiple modules comprising several microcontrollers, accelerometer sensors, and a network architecture using RS485. These components are integrated to create a robust and efficient landslide detection systems. A schematic diagram of the process system is displayed on these slides, illustrating the connections and interaction between the different modules. The proposed filtering technique aims to reduce noise and enhance the accuracy and reliability of the landslide detection systems. Continuing our discussions, let's look at the methodology we use to establish a reliable and efficient network. To ensure the proper functioning of the RS485 network, we implemented several measures. We placed termination resistor at each end of the network to prevent signal reflections and reduce noise. Additionally, we employed twisted pair cabling, which helps minimize the effects of electromagnetic interference on the communication signals. For our network topology, we choose for a multi-drop configurations. This means that multiple devices are connected to the same communication bus. The network is controlled by a master node, which sends commands to the other nodes on the network. In response, the other nodes provide accelerometer data, creating a bidirectional communication systems. To facilitate communications, each microcontroller on the network is connected to an RS485 transceiver, as shown in this slide. For this purpose, we selected the MAX485 transceiver from analog device. This transceiver, the MAX485, is known for its robustness and ability to withstand harsh environments. Now we will focus on the circuit design of accelerometer-based soil movement detection system, which incorporates the Atmega 328 microcontroller and the BMI 160 accelerometer sensor from Bosch. As shown in the figure, the circuit connection between the microcontroller and the accelerometer sensor is established through the I2C protocol. We choose the I2C protocol for its simplicity and reliable data transfer. It enables communication between the microcontroller and the sensor using only two signal lines, the serial data and the serial clock lines. This protocol simplifies the integration process, making it ideal choice for our applications. To physically realize our circuit designs, we developed a PCB prototype, as shown in this figure. These prototypes house the BMI 160 accelerometer, the Atmega microcontroller, and the Max 485 transceiver, which we discussed in the previous slides. The integration of these components in our circuit design forms the foundation of our accelerometer-based soil movement detection systems. The implementation of the exponentially weighted moving average digital filter is an integral part of our soil movement detection systems. This filter is employed to enhance the accuracy and reliability of our sensor data by reducing noise and random fluctuation in the signal. The filter operates by calculating a weighted average of the sensor data over time. The weighting factor used in the calculation exponentially decreases but never reaches zero. This characteristics allows the filter to emphasize recent data while gradually diminishing the influence of older data. In this section, the result will be discussed based on the analysis of the tilt angle data collected using the accelerometer. To ensure an accurate evaluation process, we affixed the accelerometer to a level surface and calibrated it to a tilt angle of 0 degrees. The accelerometer data was then read and converted into tilt angle measurements by the microcontroller. These measurements were transmitted to a Windows machine running MATLAB for statistical analysis and digital processing. We acquired a total of 100 data points from the accelerometer with a sampling rate of 1 Hz as shown in this slide. This plot illustrates the distribution of the raw and filtered data obtained by applying the EWMA filter with two different weight values, 0.95 and 0.65. From visual inspection, it can be observed that the weight of 0.95 results in less fluctuations compared to the weightage of 0.65. Furthermore, we calculated the mean, standard deviation, maximum, and minimum values for both the filtered datasets and the raw data. These results are summarized in this table. The analysis shows that the filtered data using the EWMA filter provides a better representation of the data compared to the raw data. The filtered data exhibits lower standard deviation and reduced variation in maximum and minimum values. This indicates that the filter effectively removes some of the random fluctuations present in the measurements. The filtered data also shows a smaller root mean square error, RMSE, compared to the raw data, indicating improved accuracy in detecting landslide events. In conclusion, our study demonstrates that the use of exponentially weighted moving average filter effectively reduces noises in accelerometer measurements of soil movement. Furthermore, the descriptive statistic of the raw and filtered data confirms the higher quality of the filtered data in terms of smaller root mean square error, lower standard deviation, and less variance in maximum and lowest values. This finding emphasizes the potential of using EWMA filters to enhance the accuracy of landslide detection using accelerometers. Thank you for your attention.